The James Webb Space Telescope (JWST) is widely regarded as one of the most sophisticated scientific instruments ever developed, and it now serves as the foremost observatory for astronomical research and space science. Its primary mission extends far beyond simple observation. It is designed to probe some of the deepest and most profound mysteries of the universe. By capturing high-resolution images and spectra from distant cosmic objects, the telescope is helping scientists uncover the nature of galaxies, stars, planets, and other celestial bodies, while revealing the complex architecture of the universe itself. Its contributions are so significant that it may redefine humanity's understanding of our place in the cosmos. One of the telescope's main scientific goals is to examine our own solar system in detail, providing new insights into the nature and origin of our planetary neighbors. But perhaps even more tantalizingly, the telescope's capabilities allow it to extend its reach to study exoplanets, planets that orbit stars outside our solar system. Through its instruments, the JWST captures light and data that reveal the atmospheric makeup, chemical composition, and potential habitability of these distant worlds. The discovery of new exoplanets, especially those that might host liquid water or have conditions favorable to life, is reshaping our understanding of what life might look like beyond Earth. One of the telescope's recent and remarkable endeavors involved observing a distant star located 120 light-years from Earth. Using its highly sensitive instruments, the telescope gathered information that indicated the presence of carbon-based molecules, essential building blocks for life as we know it on a planet orbiting this star. The presence of these molecules has sent waves through the scientific community, which is now speculating about the potential for this planet to support life. The telescope's capability to study these kinds of atmospheric compositions on distant planets provides a powerful new tool for exploring life beyond Earth. As it continues its work, the telescope will likely yield even more discoveries that deepen our understanding of the unique and varied ways planets can form and evolve across the galaxy. Among the Webb telescope's recent discoveries is one of particular importance, the planet K2-18b. This exoplanet, situated at a distance of 120 light-years in the constellation Leo, is a giant world with a mass approximately 8.6 times that of Earth. It orbits a cool dwarf star called K2-18, which resides in what astronomers call the habitable zone, a region around the star where conditions might allow liquid water to exist on a planet's surface. Previous observations of K2-18b suggested that it might have the right conditions for hosting life. The planet's atmosphere appears to be rich in hydrogen, and it might even possess an ocean-covered surface, conditions that some scientists believe could create a favorable environment for life. The first hint that K2-18b might be worth studying came from NASA's Hubble Space Telescope, which detected potential signs of water vapor in the planet's atmosphere. This discovery set the stage for further investigation by the Webb telescope, which has now provided even more compelling data. Recent findings from Webb's observations indicate the presence of carbon-based molecules, specifically methane and carbon dioxide. Both of these compounds are of particular interest to scientists because they are associated with biological processes on Earth. The presence of these molecules, alongside a lack of ammonia, strengthens the hypothesis that K2-18b might host an ocean beneath its hydrogen-rich atmosphere, as ammonia would likely be found if the hydrogen atmosphere were simply a product of chemical processes rather than a biological one. Adding to the intrigue, scientists have also speculated about the possible presence of a molecule known as dimethyl sulfide, which is unique in that, on Earth, it is almost exclusively produced by living organisms, primarily as a byproduct of phytoplankton in marine environments. This molecule's detection would be a groundbreaking finding, suggesting that biological processes might be taking place on K2-18b. However, current data is not yet conclusive enough to confirm dimethyl sulfide's presence. The scientific community is eagerly awaiting further studies and observations that could clarify whether dimethyl sulfide exists in the atmosphere of K2-18b, as it would provide one of the strongest possible indicators of life. The structure of K2-18b itself presents a fascinating enigma. Although it lies within the habitable zone, and its atmosphere is rich in hydrogen and carbon compounds, the planet is quite different from Earth. Its radius, which is roughly 2.6 times that of Earth, implies that it is not a rocky planet but rather a sub-Neptune, a planet type that is not present in our own solar system. This means it likely has a core surrounded by an immense, high-pressure mantle of ice, somewhat akin to Neptune but with unique features. Above this icy mantle lies a thinner hydrogen-rich atmosphere, and beneath it, scientists theorize that an ocean-covered surface could exist. Although this ocean might hold liquid water, it is possible that extreme pressures and temperatures make it unsuitable for life as we know it. Despite these potential limitations, the information gathered by Webb's instruments is groundbreaking. The research team has achieved the most detailed spectrum to date of a habitable sub-Neptune, allowing them to accurately identify the specific molecules present in its atmosphere. By analyzing the way light from K2-18 billion's host star filters through its atmosphere, astronomers can determine the planet's atmospheric composition. K2-18 billion, like many other exoplanets, is a transiting planet, meaning that it occasionally passes directly between its host star and Earth, temporarily dimming the star's light. This dimming effect, combined with spectral analysis, allows scientists to understand the gases and elements present in K2-18 billion's atmosphere. Beyond K2-18 billion, the Webb telescope has achieved additional, equally awe-inspiring discoveries. In a galaxy located billions of light-years from Earth, scientists have identified complex organic molecules that resemble those found in smoke or smog on Earth. These molecules, known as aromatic hydrocarbons, represent the most complex organic compounds ever detected from such a distant galaxy and are an astonishing example of cosmic chemistry. On Earth, similar molecules are found in substances like petroleum and coal, as well as in the smog that forms from urban pollution. The fact that these complex compounds have been found in the early universe challenges current models of how quickly and extensively organic molecules can form. To understand the significance of this finding, it helps to recognize that the light carrying these molecular signals took nearly 13 billion years to reach us, beginning its journey just 1.5 billion years after the Big Bang. During this period, the universe was in its formative stages, and galaxies were in the early stages of building up the stars, planets, and other structures that we see today. The discovery that aromatic hydrocarbons were already present at this time suggests that the processes for forming complex molecules were operating at a much earlier stage than scientists previously thought. Webb's observations, with their unprecedented resolution, are helping astronomers see not only the presence of these molecules, but also their precise distribution within galaxies. One particularly striking aspect of this distant galaxy, known as SP4 1847, is that it already possesses a mass comparable to the Milky Way despite being only 1/10 its age. The stars within SP4 1847 have produced carbon, oxygen, and other elements at rates that align with the star production in our own galaxy. This discovery hints that galaxies formed and evolved with incredible speed, rapidly producing the elements essential to life. The Webb telescope's sensitivity allows it to detect such distant and ancient structures, painting a picture of a universe that is far more dynamic and chemically rich than previously understood. As humanity pushes forward into the unknown, armed with scientific tools like the Webb telescope, each new discovery reinforces our sense of awe and humility before the vast and complex cosmos. With each breakthrough, we take another step toward unraveling mysteries that have remained hidden for millennia. The journey to uncover these secrets is ongoing, and as the Webb telescope and other instruments continue to probe deeper into space, we are likely to uncover even more insights about the origins, structure, and potential habitability of our universe. Our exploration network, spanning telescopes, space probes, and other technologies, brings us ever closer to understanding the universe's secrets. If you are as captivated by these discoveries as we are, please share your thoughts in the comments. To stay updated on the latest developments, consider subscribing to our channel, and be sure to enable notifications so you won't miss any new revelations from the Webb telescope's findings and beyond. Together, we stand on the brink of a new era in astronomy, where the universe may soon reveal its most profound secrets, reshaping our understanding of reality itself.